Salvation International Preparatory School. Salvation International Preparatory School. A place to be, a school to go. We'll build you up from the cradle to university. Salvation International Preparatory School. Salvation International Preparatory School. A place to be, a school to go. We'll build you up from the cradle to university.
Good afternoon, class.
Good afternoon, Auntie.
We are all welcome to class this afternoon. Today we'll be looking at basic science, and the topic is matter. Can we say it together?
Matter.
Thank you very much. Matter is defined as anything that has weight and occupies space. Matter is anything that has weight and occupies space. Now, the weight of an object can simply be measured when we use a scale. Many of us go to the hospital and they ask you to stand on a scale. They are trying to measure your weight. So any object that has weight and that can take any space or position given to it, that object is said to be matter. So long it has weight and it can occupy any given position, such an object is called matter. So this marker, does it have weight?
Yes, ma'am.
Is it occupying a space?
Yes, ma'am.
So we call this what?
Matter.
Yourself, do you have weight?
Yes, ma'am.
Are you occupying a space?
Yes, ma'am.
So you are said to be what?
Matter.
So any object that comes in mind, that comes to your mind, and so long it has weight and occupies space, is called what?
Matter.
It's called what?
Matter.
Alright, on the board here we have a few examples of matter: sand, chalk, books, cars, buildings, chairs, plants, animals, water, gas, air. Anything that has weight and occupies space is called matter. Now the next subtopic is components of matter. When you hear the word components, it means what makes that thing up. What does it consist of? What is it all about? What builds it up? So the components of matter are basically two for our class and our level now. We're looking at atoms and molecules. So matter is made up of atoms and molecules. The next question would be, what are atoms? Now, atoms are the smallest part of any substance. Remember, we said any substance or any object that has weight and that occupies space is said to be what? Matter. So the smallest part of a matter that can take part in a chemical reaction is called an atom. So an atom is the smallest part of any substance that can take part in a chemical reaction. Now the next giant word there is chemical reaction. Now chemical reaction is simply a process that causes change in any substance. Chemical reaction is the process that causes change in any substance. For example, mommy wants to make oil beans. She will have to pick what? A raw beans. After picking, she puts inside the pot and she cooks for a while. Is that not so?
Yes.
Now, after heating for some time, when you check the beans, how does it look? Soft and darker in color. Is that not so? Now that means that beans has what? Changed. It has gone through a process that has caused what? A change. That process that created that change is what we call chemical reaction. So the smallest part of that beans that can take part in that change is what we call an atom. So atom is simply the smallest part of a matter or of a substance that can take part in a chemical reaction. Now I want us to go back to our English class where we looked at singular and plural. We said singular consists of one word, object or item, while plural consists of two or more items or objects. The same here, atoms are seen to be the singular here and molecules are the plural. So molecules are formed when two or more atoms are combined together. Molecules are formed when two or more atoms are combined together. So atoms become the singular, while molecules become the word plural. Are we following?
Yes, ma'am.
Thank you very much. So we'll go back through the definition. Please, what are atoms?
Atoms are the smallest part of a matter that can take part in a chemical reaction.
Thank you very much. Now, what are molecules?
Molecules are formed when two or more atoms are combined together.
That's excellent. Thank you very much. Now we go to the next subheading, states of matter. Now, if you agree with me from our definition, we say matter is anything that has weight and occupies space. Matter is a form of, it's an example of matter. Water is an example of matter. Air is an example of matter. But do these three exist the same way?
No.
Do these three exist the same way?
No.
That means matter can exist in different forms. And the basic three states in which matter can exist are simply solid states, liquid states, and gaseous states. Can we say it together?
Solid state, liquid state, and gaseous states.
As a parent, I have always asked, how can I prepare my children for the infrastructural development and socio-economic evolution of the next decade? With the ongoing speed of globalization, how can I position my children to perform excellently in a rapidly changing society? The answer is and has always been to give them a solid foundation, academically, spiritually, and morally. Salvation International Preparatory Schools, with her team of highly qualified tutors, conducive environment for learning, state-of-the-art computer and science laboratories coupled with quality day and boarding facilities, is the place to be. For more information, contact 080-233-76135. SIPS remains the birthplace of leaders.
Now the question that comes to mind is, what determines the state in which a matter will exist in? Why is it that all matters are not solid? Why are they not all liquid? And why are they not all gas? Why are some solid, others liquid, and the rest gases? This is because of the bond or the force that keeps the atoms or molecules of matter together. Now, we said before that atoms are the smallest parts of a matter, and that molecules are formed when we combine two or more atoms together. For us to combine them together, it means that there is a force that puts them together. So the nature of the force, the kind of force that exists between these atoms and molecules of any object, of any substance, determines if it will be solid, if it will be liquid, or if it will exist as gas. So what I'm saying is this: the kind of force or bond that keeps the atoms of an object or of a substance together determines the state in which matter will exist in. Now we'll go to the characteristics of solid states. characteristics of solid state. Before we go there, I'm going to mention a few examples of matter that exist as solid. Benches, your chair and table, this board we are using, this building, the fan, they are all examples of what? Matter, or matter that exists in solid state. Now, what are their unique characteristics? What makes them different from liquid and gases? Number one is that the atoms and molecules of solid states are held together by strong attractive force. Or you say they are held together by strong bonds. What links the atoms of solid states together are very, very strong. And so because it is strong, the spaces between them is very short. They are closely related. Your relationship with your parents and your relationship with your teacher, which one is stronger? Your parents. So the bond between you and your daddy is stronger than the bond between you and your what? Teacher. So also in atoms for solid state, the bonds between them is very well, they are very well strong. So they cannot move away. They always stay together. Are we following? This kind of bond are called electrovalent bonds. The bonds that links atoms and molecules of solid are called electrovalent bond, and they are the strongest kind of bond that can keep atoms together. Number two, because of this force, this strong force that is existing between the atoms of solid states, the particles, that's the atoms and molecules, the distance between them are very short. The distance between the particles, that's the atoms and molecules that make up solid state, are very short. So they are closely held together because the force is strong to keep them all bounded together. Now, because of this force, they have a definite shape and a definite volume. All true solids have a definite shape. If you look at this marker, what's the shape of this marker? Cylinder. It's cylindrical. Now, this marker can exist in this shape. Even if I try to compress it, the shape remains. That's because the force holding the atoms of this marker are very well strong. So it has what? Solid now have what? Definite shape and a definite volume. The space this marker is occupying in my hand is definite. It cannot be wider than what? This. The space I am occupying here is definite. It's fixed. It's not wider than what? This. So atoms or solids, because of the kind of bond that exists between them, they have definite shape and volume. Number 4, the particles of solid cannot move due to the strong attractive force. But what they do is they vibrate about their position. They only vibrate about their fixed position. So instead of them trying to move around, when they want to try to move around, because the force holding them is strong, they remain in that position. If I'm to hold her hands and say don't go anywhere, because my force is stronger than even if she tries to go around, because I'm holding her, she will remain in this position. So the force holding the atoms and molecules of solid are strong enough to keep them in one place. So when they try to move, they simply vibrate. Now, when we heat solid, when we decide to increase the temperature by heating it, solid behave by changing from that solid state into liquid state. This happens because the heat increases the vibration of the atoms and molecules. And once they have sufficient energy, they can now lose themselves from the world, force holding them together, thereby changing into what? Liquid.
Salvation International Preparatory School. Salvation International Preparatory School. A place